on ANSYS Workbench tutorials. In this session, we are going to analyze a drill bit for its modal analysis. We will start by double-clicking on module. We will first go to engineering data. There are various types of materials used for the drill bit, namely stainless steel, cemented carbide, tungsten carbide, carbon steel, D2 steel, and many more. So we are going to use 2 or 3 of these materials to analyze the drill bit. We will start by choosing stainless steel, which is already present in general materials. This is one material which I have chosen. Apart from this, I will enter data for carbon steel. The density of carbon steel is 7850 kg per meter cube. Next, we'll go for isotropic elasticity. The value of Young's modulus in megapascal is 2.1 E5 and the value of Poisson's ratio is 0.29. Next, let's enter the data for tungsten carbide. First, we'll give the value for density. It is 15630 kg per meter cube. Next, we'll add isotropic elasticity. The value for Young's modulus in megapascal is 53,000 and the value of Poisson's ratio is 0.31. So these are the 3 materials that I'm going to use. I'll go to project now and update project. After adding material, I'll go to geometry and right click. I'll directly insert the drill bit model. Next, I'll go to model and double click on it. First, I'll go to geometry and I'll change the material. Next, I'll go to mesh. I'll change the sizing to fine and update. Next, I'll go to model and right click and insert fix support. And apply. Next, I'll go to solution and solve. You can see here 6 modes have been created. I'll right click here, select all, right click, create mode shape results. I'll go to solution and solve once again. So now you can see there are 6 modes and 6 frequencies obtained. When you go to the first deformation, the value of frequency is 627.86 Hz and the maximum deformation is 581.93 mm, which is quite a high value. Next, the value of frequency is 693.3 Hz and the maximum deformation is 596.76 mm. You can check this animation. For deformation 3, the value of frequency is 3831.7 hertz, and the maximum deformation is 607.3 mm. The maximum frequency in general for the drill bit is 50 hertz. So what we are talking about is essentially quite high. But if this frequency is attained by any other object vibrating around it, then it can go in the mode of resonance. So that is the requirement of studying the modal analysis of the drill bit. Next we'll see the fourth deformation. The value is 623.76 mm, and the value of frequency is 4241.2 hertz. For the fifth deformation, the maximum deformation value is 618.5 mm, and the highest frequency here is 6454.4 hertz. You can see the table. And for the sixth one, the maximum deformation is 555.1 mm, and the value of frequency is 9808 hertz. And this is the mode of its vibration. So this is all about the deformation using stainless steel as a material. Now let's use tungsten carbide as a material and solve once again. Using tungsten carbide, you can see that the frequency is now 231.68 hertz, and the value of highest deformation is 409 mm. The pattern of motion will remain the same irrespective of the material that you use. So we will not see the animation once again. It's not required. You can animate and check in case you want to tally for all the other materials. Now for the second frequency, the value is 255.8 hertz and the maximum deformation is 420 mm, as you can see. So accordingly, you can just check for each frequency, the value of deformation is definitely lesser as compared to the previous case, and so is the value of frequency. We started with 600 hertz here, and now we are starting with 231 hertz. So the first natural frequency for tungsten carbide is lesser as compared to stainless steel. And accordingly, you can compare all the other frequencies and their deformation. Now let's take up carbon steel as a material and solve once again. Here you can see again the frequency is 651.17 hertz for the first mode, and the deformation is 578.16 mm. When you go for second deformation, the value of frequency is 719.27 hertz and the deformation is 592.9 mm. Here the value of frequencies are higher as compared to what you obtained in stainless steel. The deformation could be close values, that's what I can see. It's close to the ones that we had, but these frequency values are higher. So you can obtain the same amount of deformation, higher frequencies, which is better because it is difficult to attain higher natural frequencies. So if given a choice, you would have to choose carbon steel because it is giving you better frequencies. There is higher frequencies and lesser or equal deformation as compared to stainless steel. But when you talk about tungsten carbide, you can clearly see that the frequencies that we obtained were lower. 50 hertz is its actual value, working value. But when you are having 230 as the first natural frequency, which is higher as compared to 50, it is easier to reach or attain. So I would prefer steel as a material as compared to tungsten carbide so that my results are better. So that's how you compare the three materials for a drill bit and decide on which material would be better as far as modal analysis is concerned. So with this, I end the session. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.